Welcome to the another video in the compendium of limits. In this particular video, we shall solve actually few problems of trigonometric limits. So this is the first problem, in which function Sn is defined as summation of series of sine, and we can see that the angles of sine are in AP, okay, with the common difference x. So we can write actually Sn as summation of sine Rx and R equals to 1 to n. Okay, this is Sn. We can, and because the angles are in AP with the common difference x, so what we can do is we can actually multiply 2 sine x by 2 in numerator and denominator and see what we are getting. 2 sine x by 2 in numerator and 2 sine x by 2 in denominator. Okay, and then here we'll have sine x plus sine 2x all the way up to sine of nx. Okay, now we can see that in numerator we are getting this thing out first. In numerator we are getting 2 sine x by 2 into sine of x, again 2 sine x by 2 into sine of 2x all the way up to here 2 sine x by 2 into sine of nx. Okay, now this is sine into sine, so this will be a difference of cos, and we can write this as difference of, and we can write this as 1 upon 2 sine. I'm just carrying this out, and we can write this as cos x by 2 minus cos 3x by 2. Okay, we can write this thing as cos 3x by 2 minus cos 5x by 2. Okay, and all the way up to, we can write this as, I think, cos, and yes, cos, and this is 1 minus half, this is 1 plus half, this is 2 minus half, and this is, yes, so this will be n minus half x minus cos n plus half into x. Okay, now we can see that this every term is getting cancelled here, so this will get cancelled till this. Now this becomes 1 upon 2 sine x by 2, 2 sine x by 2, and this as cosine of x by 2 minus cos of n plus half x. Okay, so this is what we can get. Now we have to find this is Sn. Now we have to find so this is Sn, but now let us generalize this. Then SR would be 1 upon 2 sine, I think this would be carried, yes, it would be carried again, because let me just think, yes, this is 1 upon 2 sine x by 2, and this would be cos of x by 2 minus cos of, and this thing is actually n, so don't get confused by n and x. This is, and because we are defining for rth term, so this would be r plus 1 by 2 into x. Okay, so this is SR. Now we have to find summation of SR from 1 to n, so we have to find summation of SR from r equals to 1 to n. Then it would be 1 upon 2 sine x by 2, and summation of cos x by 2 n times is n times of cos x by 2, and minus this would be cos, we will put r equals to 1, then r equals to 2 and all that, and so this is summation of r equals to 1 to n, and cos of r plus half into x. Okay, now we have to find limit n tends to infinity summation of SR r from 1 to n upon n. Okay, this is I'm writing it here. I'm writing this thing here. This is 1 upon 2 sine x by 2. Okay, and we have to multiply n 2. Yes, we have to divide it by n. So yes, so this is n times cos let me think it. This is n times cos x by 2. Okay, and this n would be here. Okay, and this minus again here, and this is summation of cos r plus half x, and this r equals to 1 to n divided by this n. Okay, okay, so we can see that this n is and this n is getting cancelled here, and since it is given in the question that x does not belong to 2k pi, and therefore cos r plus half into x, okay, does not is not equals to 1, and this thing is also less than 1. Therefore this thing is less than 1 and denominator we have infinity, so this goes to 0. So this limit comes out to be 0. Therefore our actual limit is 1 by 2, and this is cos x by 2. This is half, and this is cos x by 2, and sin x by 2 is cot x by 2, and that's what we have to prove, and we have proved that. I think this would help. So this is the first question. Let's talk about some other questions. Now this is the another problem that involves trigonometry in limits. So we have a function that is f of n and theta, and that is continuous product of 1 minus tan square theta upon 2 to the power r. So we have to find the limit n tends to infinity f of n theta. Okay, so let's solve it. So here we can see that if we if we divide it by 2 tan into theta to the power theta upon 2 to the power r, we will get tan theta upon 2 to the power n minus 1. Okay, so let's do that. I'm gonna first analyze this. So what I'm gonna, so f of n into theta equals to pi continuous product r equals to 1 to n. Okay, and this is 1 minus tan square theta upon 2 to the power r upon so what I'm going to do is I'm going to multiply 2 into tan theta upon 2 to the power r, and because I've divided it by this, I will multiply it also. So this is 2 tan into theta upon 2 to the power r. Now I just did this manipulation just to get a form of tan 2 theta. So we can write this thing as 1 upon tan 2 to the power tan 2 theta, and if theta is this, then 2 theta would be tan theta upon 2 to the power r minus 1. Okay, this would be order, and here we have 2 into tan theta upon 2 to the power r. Okay, now, and this is actually a continuous product, so we have to multiply it from 1 to n. Okay, so we have to multiply it from 1 to n. Now what is this? Just starting just putting values of r. So this is 2 to the power n, because we are going to multiply it n times. So this is 2 to the power n, and here we can see that it is tan theta by 2. upon tan theta. Here we can see it is tan theta by 4, and here it is tan theta by 4, and here it is tan theta by 2. Here we can see it is tan theta by 8, and here it is tan theta by 4, all the way up to tan theta upon 2 की power n divided by tan theta upon 2 की power n minus 1. Okay, now we can see that this everything is will be cancelled here, so this everything will be cancelled, and we will be left with, here we can see that we will be left with f of n theta would be, f of n theta will be actually equals to this would be 2 to the power n into tan theta upon 2 to the power n upon tan theta. Okay, this tan theta, because this is only that is left in denominator, so we have to find, and therefore limit n tends to infinity f of n into theta equals to limits n tends to infinity 2 to the power n tan theta upon 2 to the power n upon tan theta. Okay, what I'm going to do is, we know that this thing is tending to 0, and we know this particular limit x tends to 0, tan x upon x, that is equals to 1. So we have to create this particular thing in denominator also. So I'm going to multiply it with theta upon 2 to the power n, because I have multiplied it here, I will multiply it here, and so this will be cancelled, and this particular limit will tend to 1. So our answer would be theta upon tan theta. So that's the second problem. It's a nice problem, not so difficult, not so easy. So let's solve another problem, and let's understand some more basics and more important problems of trigonometry in limits. So this is another problem that involves trigonometry in limits in a very beautiful way. This is a very beautiful mangle of trigonometry with limits and with algebra too. So let's solve this. We have a function fn that is defined as continuous product of 1 plus sec x, where the angle of x are in, the angle of secant is actually in AP with a common difference, sorry, it is in GP with a common ratio 2. Okay, so we have to find limit x tends to 0 fn x upon 2x. So let's solve it. We can see that we can write this as, I'm just in order to simplify this, fx is tan x by 2. Okay, and we can write this as, I'm just, let me, yes, we can write the 1 plus sec x as cos x plus 1 upon cos x, and we can write this sec 1 plus sec 2s as cos 2x plus 1 upon cos 2x. Okay, we can write this as cos 4x plus 1 upon cos 4x, and all the way up to here, sorry, this is multiplication, so all the way up to multiplied here, cos 2 to the power nx plus 1 upon cos 2 to the power n into x. Okay, now we can see that the formula of cos 2 theta is, 2 cos squared theta minus 1. Okay, so if we multiply 1, if we add 1 here, then this becomes 2 cos squared theta. So we can use the same here. So we can see that this is actually tan into x by 2, and this is actually we can see this is 2 cos square x by 2 upon cos x, and this is 2 cos square x upon cos 2x, and this will continue here to 2 cos square 2x upon cos 4x, and all the way up to cos square 2 cos square 2 to the power n minus 1x upon cos 2 to the power nx. Okay, now we can see that these every terms are getting cancelled here. So these are getting cancelled, so this will cancel. So and we can see that this is 2 to the power n, because 2 is getting multiplied n times 2 to the power n, and here we can see that this is sin x by 2 upon cos x by 2. So this cos x will actually cancel this cos x2 also. So I'm just gonna write sin x, okay, for simplicity. And in numerator, what we are left with is this is, let me write in a more coherent way, this is sin x by 2. And in numerator, what we are left with is cos x by 2 into cos x into cos 2x into all the way up to cos 2 to the power n minus 1 into x. And in denominator we have just this particular term, because this is the only term in numerator in denominator that didn't get cancelled. So this is cos 2 to the power n into x. Okay, so this is what we are left with. Now if we multiply 2 here, if we kind of steal 1 2 from this and multiply it here, we'll get sin x, and we'll get sin x, and sin x into cos x will again, if we multiply 2 again here, then this will become sin 2x. So this will become continuous, and this will become at last sin 2 to the power nx. Okay, because I'm just going to explain it how. So this is 2 to the power n minus 1x, and this is 2 sin x by 2 into cos x by 2, it is sin x. Okay, and again here cos x and cos 2x all the way up to cos 2 to the power n minus 1x. So every time you will have, you again multiply it 2 here, and you will again get sin 2x, and again sin 2x into cos 2x with 2 is sin 4x. So all the way goes up to sin 2 to the power nx. Okay, and by writing 2 to the power nx, we have left with no 2 before we are left with no 2 in the numerator, and we have in denominator cos 2 to the power nx. This is actually tan 2 to the power nx. Okay, and this is actually equals to f of n into x. Now we have to find, now what we have to do is we have to find limit x tends to 0 fn x and 2x here. This is tan 2 to the power nx upon 2 into x. Okay, now we know that this particular term, so this is we can see that this angle is getting 0, and we are familiar with this limit, that if limit x tends to 0, tan x upon x equals to 1. So we have to create this particular term in denominator, and we have a 2 here, so we have to multiply it by 2 to the power n minus 1, and because we have multiplied it here, we have to multiply it here too. Okay, and we can see now this particular term is getting 1, so this limit is actually 2 to the power n minus 1. So that's a beautiful problem, and an easy one also. So this is option number C. Okay, so that's all for today. I think this would help. Please like, share and subscribe. Thank you.